All right, good morning, everybody. Today we'll just start off with some warm-up questions to make sure we are keeping up with some of this content. I think the carryover between multiple days of the same concept is a great way to try and solidify some of the concepts. So I just wanted to put this reminder here, and this will help us see the macro operation of what's happening, right? The takeaway from a lot of this is in order to write in order to write these equations of lines, all that is required of us is either 2 points in which we can use those 2 points to find a slope, and then we can use a point or a slope to find the equation of a line. So all we need is either 2 points or a point and a slope. The only difference between this case is we use the 2 points to find the slope. So it just has one extra step. But then after we find that slope, we have the slope at more than a single point. We have 2 points to choose from. But if we know the slope and a point right away, then we don't need to do that extra step in order to calculate the slope using that formula. But in this case, we have a couple different examples of different types of information that's given to us. So remember what I said, generally we probably want to use the y minus y1 equals m times x minus x1 formula. It's more general and it's easier for us to use a larger variety of information to try and create this equation and plug in the values that we know. And then we can always simplify it into the y equals mx plus b form. The mx plus b form is a little more annoying to deal with, but it's still just as valid. So let's try this out. So if I read this, the equation of the line I know will pass through 1 comma 2, and it has a slope of -4 comma 5. So we're in this category. We have a point and a slope, and we can just plug in now. I know right here is my x1, y1, and here's my m. So I can plug into the formula. Y minus 2 is equal to -4/5 times the quantity x minus 1. And don't forget that parenthesis, because that parenthesis does matter, because the -4/5 is multiplied to the -1. Now, I'm going to simplify this a bit, because I said we want to write our final answers in y equals mx plus b form. So on the left-hand side, I'm not going to do anything yet, but I'm just going to distribute this 4/5, this -4/5, into the expression. When I multiply -4/5 by -1, it will become +4/5 out here. So right now I have this equation. And what I need to do now is add this remaining 2. So right now my final answer is looking like this. And I can combine this 4/5 and 2. What I need to do is write 2 as a fraction involving 5. So what I'm going to do is rewrite this 2 as 10/5. That's the same thing as 2, but now I can add these two fractions. And that is our equation of a line in y equals mx plus b form. So in this next question, we're told that the y-intercept is 2 and it goes through the point 4 comma -1. And this is a little tricky because it's not as clear as when I just give you 2 easy or maybe more blatant points like this. But if I were to translate this y-intercept into an actual x comma y point, this would be 0 comma 2. That's a y-intercept right there. And this would be 4 comma negative 1. So if I, covered all that up and said, find the equation of the line going through these 2 points, you would know how to do that, because now we can find the slope. It's going to be y2 minus y1 over x2 minus x1. So don't be fooled when the question looks different. It might at its core be the same type of question. We have 2 points. We can find the slope between those 2 points, and then we can pick either of these points to be the ones that's going to be in this point slope form. So we'll calculate this real quick. I will call this x1, y1, and this x2, y2. So y2 is negative 1, y1 is 2, x2 is 4, and x1 is 0. This is negative 3 over 4. And this is the hardest part. Now we have our slope, and now we have 2 points that we can pick from. Let's pick 0 comma 2 just for simplicity. So when I distribute this negative 3/4 into this parenthesis, all that it gets attached to is to this x, because I'm subtracting 0 inside the parentheses. So this becomes y minus 2 is equal to negative 3/4 x. And then I can just add the 2 to the other side. So my final answer is this. And this matches up because if you think about this right here, this is also, I call it I just say y equals mx plus b, but it's also the slope intercept form where b is the y-intercept. And right here, if you see, this is the y-intercept and b is still the y-intercept too. So it works out. So this was what we did at the very end of class yesterday. We want an equation of a line that's perpendicular to this line. Oops. And it goes through this point. So again, think about the broad picture. All we need is a slope and a point to write an equation of a line. So we know how to find perpendicular slopes. Let's first just determine what the slope of this line is. What I'm going to do is take this equation of a line, and I need this to be equal to y. So I don't want that 3 over there. So the slope of this line is 1/3. Now I need a slope that's perpendicular to this slope. Anybody want to suggest what that perpendicular slope is?
-3.
Yep, it's -3. It's the reciprocal, the negative reciprocal of 1/3. So what I'm going to do is flip 1/3, but that becomes 3 over 1. So that's 3. Did you say -3 or did you say -1/3?
-3.
Okay, great. So now we just plug in the points. Y minus 1, -3, x minus -2. So since I'm subtracting a negative, I'm going to add an additional parenthesis so we keep those negative signs correct. So it becomes x plus 2 inside the parentheses. Y minus 1 is equal to -3x minus 6, because when I distribute that -3 to +2, it becomes -6. And I'm going to add 1 to both sides to get y equals -3x minus 5. And that's an equation of our line. And now this is the most basic case. I have 2 points in space, and I can figure out an equation of a line. So does anybody want to point out something that's special about these 2 points? It can just be a general idea. It doesn't have to be super exact.
It's only gonna be a horizontal line because they both pass through y equals 7.
Yep, exactly. So if you notice right here, this will be a horizontal line because for different x values, they have the same y value. So if we just kind of imagine that on an axis, for different x values, they have the same y values. So it's a horizontal line going this way. And right away, the horizontal line is this similar y value. It's y equals 2, and you're done. That is the equation of the line that's being described right here. If I were to do it the other way around, if it was 7, 1 and 7, 3, well, let's think about it on an axis again. For different y values, I have the same x value. So it looks like this, and it's a vertical line. And the vertical line has the equation x equals 7. And you're done. So this is why when I emphasize that it's important to describe intercepts as points rather than lines, because what this does right here is if you say an intercept is x equals 7, what you're describing is an equation of a line, not a point. An intercept is a specific point, not an equation of a line. So if I say find, when we talk about later, like a maximum point of a function of a graph or something, if you tell me, oh, it happens at x equals 2, sure, it does happen at x equals 2, but we're talking about a specific point. So I need that 2 comma whatever the y value is. So it's important to be careful on how you notate your answers, because points are different from equations of lines. That's just a little side note for us, though. Put that over there. So any questions about these examples? So I think this is a good variety of questions and shows you how you can use the given information to figure out the pieces that you need to write the equations of the line. Am I given 2 points? Am I given a slope and a point? Things like that. But for now, we will move on. So today we're going to be talking about word problems, with linear equations, and then problem solving, which is kind of a broad topic. There are some word problems sprinkled in here, but the actual section in the textbook is more centered around general solving of maybe slightly more difficult algebraic expressions. But we'll talk about word problems first. So obviously, when you're talking about graphs or functions like this, so when we have like equations of lines like that, what you can do is describe a lot of real world phenomenon. For example, you want to sign up for a gym. So you want a gym membership. And I tell you, okay, you can sign up for a gym membership. It's going to be a $25 upfront cost. And then after that, it's going to be $30 a month. What we can do is we can write down an equation that will describe your total cost for as many months as you want. So I'll say X describes months. So X is a variable and it is in months. And I can say, oh, your total cost, so C of X, for example, or we'll just say C, so cost It's going to be that $25 upfront cost plus $30 times X, as many months as you want to buy. Notice I don't have to attach the X to 25 because you don't have to pay the $25 every month. You just have to pay it once. So that's why it gets separated from this X. But after that, every month you pay will be $30. So let's say you want to buy 10 months of subscription of a gym membership. What I can do is I can tell you exactly how much that will cost right away. I'm going to plug in 10 into this cost equation. That's 10 months of membership. So if you want to buy 10 months of membership, it'll be $325. So this is where linear equations are really handy. They describe a lot of really interesting things. Obviously, you could calculate this yourself fairly easy without having to get into the math of it, but this is a pretty simple example. So let me pull up some other ones. So what I'll first do is describe how generally we're going to solve questions like this. It's hard because math is usually pretty self-contained, but word problems are interpretive, meaning you really have to read the problem carefully in order to interpret it correctly. So how? What we're going to do first is identify all known quantities. Assign variables as needed. To represent unknown things. That's the whole point of the variable. It's something that can change, something that we know is being described, but we don't know exactly what it is. And that's where math becomes super powerful. So I'll just say to unknown things. If there are multiple unknowns, for example, we probably won't be dealing with more than two. So we'll say two unknowns. We should try to write one unknown in terms of the other. And you'll see what I mean by that in a bit. We should write an equation interpreting the words as mathematical operations. And then the fifth one is a little broad, but then after that we solve. But once we've done all of these things, we should have enough information to at least see the breadcrumb trail on how to arrive at the final answer. So let's try some examples. Here's a good one. So 3 times a number added to 4 times the number is 40 or 84. What is the number? So this is kind of challenging. It's really a simple statement, but actually putting it into mathematical terms is really hard because word problems are hard. Let's first figure out what is the thing that's unknown. What am I trying to find? Any idea?
Whatever the number is.
Yep, we're trying to find a number. So what I'm going to do is assign a variable name to it. I'm going to call it n. So n equals the number. Now, let's just try to interpret this mathematical expression as best as we can. It says 3 times a number. So that's 3n. 3 times a number. Added. So that's a big thing. It says added to 4 times a number. Let's say 4 times a number. So that means if I add 3n and 4n, right? 3 times a number added to 4 times a number. We are talking about the same number. That is important. And these are not different numbers. They're the same number. And then when it says is 84, that means it's equal to 84. So if I say 3 times a number added to 4 times a number is 84, this is how you would interpret mathematically. 3 times a number added to 4 times a number is 84. And now we can solve for this. 3n plus 4n is 7n. Divide both sides by 7. And n will be 12. So if I were to multiply 12 3 times and multiply it 4 times and add them together, I would get 84. That is the final answer. So that number is 12. It's not too bad. Let's continue in the number category and maybe talk about a harder example. So now I'm going to talk about 2 different numbers. The larger of 2 numbers is equal to 3 times the smaller number. If twice the larger number is added to 3 times the smaller number. The sum is 27. Find the numbers. So if you notice right here, in this question, it's very short because what I'm talking about is a single number. And what I have is 2 statements about the same number. So writing it down becomes very easy. But now the larger of two numbers and the smaller of two numbers, we're talking about two different numbers. These numbers cannot be the same number. So this problem is longer because I need to do additional work in order to figure out what both of these numbers are. So let's just add some variable names for it. What are some unknowns in this question? What are some things I'm trying to solve for? Anybody want to volunteer?
Smaller number and larger number?
Yep, exactly. I am trying to find a larger number and a smaller number. So let's add some variable names. What I'm going to do is call the larger number n, capital N. Ooh, maybe I won't use capital N because I don't want to use lowercase n for smaller number. What I'm going to do is say L is the larger number. And S is the smaller number. So let's just try and write this down piece by piece. The larger of two numbers is equal to 3 times the smaller number. So I'm going to write that down. This statement says the larger of two numbers is equal to 3 times the smaller number. So this is something that's true always. This is something that's going to be very, very useful for us. But now in the second part, it says twice the larger number. So if twice the larger number is added to 3 times the smaller number, the sum is 27. And that kind of sounds like the verbiage we had above. If twice the smaller number is added to 3 times, oh, sorry, is the larger number. 2 times the larger number is added to 3 times the smaller number, the resulting sum should be 27. And if you look right here, this is very important. If you have two unknowns, you need at least as many of that number of equations to solve for it. So if I have two unknowns, I need two equations to solve for both of them. So put that over here. If I have, I'll call n unknowns, so just some number of unknowns. I need at least n equations to solve for all unknowns. Our questions probably won't go for more than 2 or 3 unknowns. Though beyond that, the difficulty is probably jumping from 1 to 2 unknowns, but the difficulty from 2 to 3 unknowns is not as big. It's actually probably simpler. So if you recognize that you have 2 unknowns in this equation, immediately you should think, okay, I need to figure out how to find 2 equations from the information that's given to us. Because if I were to cover this up and say, this is the only equation you have, there's no possible way, well, maybe you could just guess some different numbers, but in harder questions, there's no possible way to solve for both L and S in any, really clean way. So here's what we're going to do. We're going to go back up and look at what we're supposed to do. If there are multiple unknowns, we should try and write one variable in terms of the other. And that's what we have right here. We have L in terms of S. This is what this means. This is L in terms of S. And all we need to do now is use one of these equations to get rid of one other equation in the other one. So what I'm going to do is I'm going to get rid of L in this equation by substituting what L is in terms of S. This is where it gets tricky. So if L is equal to 3s. Both of these equations must be true at the same time. So what I'm going to do is plug in I'm going to plug in what L is in terms of S. So now I can get rid of L in this equation and say, oh, L is 3s. So let me just plug that in. But now this is a linear equation that is just in terms of S, and I can solve for S now. So 6s plus 3s is 9s. It's equal to 27. Divide both sides by 9, and s will be 3. So the smaller number is 3. We're not done yet, though. We want to find what the larger number is. So let's go back up and rally with the original equations. We do know, though, there is this relationship between the smaller number and larger number. The larger number is 3 times the smaller number. If the smaller number is 3, that means the larger number is 3 times 3. So it's 9. So the larger number is 9. Find the numbers, it's 3 and 9. So now what we're going to do is describe some, actually, twice the larger number times 300. If twice the larger number is added to 3, oh yeah, I'm sorry, I'm confusing myself. Okay, so now we're going to move on to some other types of questions, but there's still going to be word problems. The concept will be, though, that they are describing some physical relationships. So, for example, what is the area of just some rectangular shape? So if I wrote this rectangular shape right here, this is width and this is length. What is the area of this rectangle?
Length times width.
Yep, length times width. What is the perimeter of this rectangle?
Two length plus two width.
Yep, exactly. All I'm going to do is add all of the sides together to find the perimeter. The perimeter is the length of the distance that it would take to completely go around this object. So if this is L and this is W as well, what I have is a W and another W, so it's 2W, and then an L and another L, which is 2L. So the total distance around the rectangle is 2W plus 2L. And then what if I make this a 3-dimensional object? Here I have length, width, but now I have this additional dimension of height. What would the volume of this box be? So the volume of a rectangular box is going to be length times width times height. So length times width times height. And notice in this equation, I have 3 unknowns. I have length, width, and height. So if I have any question regarding volume, I'm going to need at least 3 equations to solve anything regarding this problem. Here, I have 2 unknowns in terms of area and perimeter. So in those type of questions, I will probably only need 2 equations to solve for any problem involving that. So let's try it out. I tell you the length of a rectangle is 4 centimeters more than the width. If the perimeter is 44 centimeters, what are the dimensions? The dimensions being length and width. So let's read this carefully. Let's try and pick out the pieces of information that are useful for us. The length of a rectangle is 4 more than the width. That's interesting. Let's see if we can describe that in terms of an equation. So when I see is, I always think equality. So length is, and now it's describing some relation between 4 centimeters and the width. And it says it's 4 centimeters more than the width. So whatever width is, it has to be 4 centimeters more. That's how we interpret this statement. The length of a rectangle is 4 centimeters more than the width. What if I change this? What if I took this exact sentence and I said more than 3 times the width? How would this equation now change? What would be on the right side of this equality? So instead of just W, it will be 3 times W plus 4. So the length of a rectangle is 4 centimeters more than 3 times the width. It is an additional 4 centimeters larger than 3 times the width. And this works with any number I put in here. This might look a little bit confusing, but any multiple of the width works. I could say instead of n, maybe it's 1/3 times the width. So the length of the rectangle is 4 centimeters more than 1/3 times the width. So then it'd be 1/3 out here. So just be careful in how minor changes in the question will affect some of the equations. And on the worksheet, I actually have a question that's very similar to this. In one of them, it's just 6 feet more than the width, but then the other one is 6 feet more than twice the width. And those small subtleties change the question vastly. So be careful. For now, we'll put that over there and we'll continue with the question. So now we have a good idea of what this is describing. We have the piece of information that we should have gotten from the sentence. Now let's look to the next part. If the perimeter is 44 centimeters, what are the dimensions? So this is the question statement. And the only piece of information we get after that is the perimeter is 44 centimeters. But we know the perimeter of a rectangular shape. The perimeter is 2 width plus 2L, and I know it's equal to 44. So what I'm going to do is just erase this perimeter piece. This is what this is. 2W plus 2L is the perimeter, and I know the perimeter to be 44. And now we have our two equations. What I'm going to do is use this equation that looks kind of more simple to substitute out one of the variables over here. Once I substitute out one of these variables, I will have an equation involving a single variable that I can solve for. We're going to repeat what we did up here. What we did up here was I had two equations. I had two equations up here. And what I did was I used one of them to get rid of one of the variables. I got rid of L up here, and this was a statement just about S in this question. And then I solved for S, and then I went back up and I solved for what L was. And that's the exact same thing we're going to do down here. So what I'm going to do is do 2W plus 2 times, and what is L? L is W plus 4. So in the parentheses, this is important. We need to put this in parentheses. Where I previously had hell, L, not hell, maybe we are in hell with the word problems. What I'm going to do is substitute L, which is W plus 4, for L. And now this is an equation involving just W. And I can solve for W. Once I solve for W, I can solve for L. So let's simplify. If you recognized at the very beginning that you could get rid of a 2 in every term and factor it out, that's totally fine as well. But it won't always work out like that. So I'm just trying to show you how in general you can do this. If you see a shortcut, feel free to do that. So the width is 9. Now I'm going to repeat what we did above. I know the width is 9, but what is the length? So I'm going to go all the way back up here and answer the question. That was a really bad arrow. I know W to be 9, so I'm going to plug in 9. So the length is 13. And the width is 9. And just common sense check, that makes sense. The original statement was that the length was 4 centimeters greater than the width. The length certainly is 4 centimeters greater than the width. We should answer the question though. These are in centimeters. So the dimensions is 13 centimeters by 9 centimeters. Any questions on this example so far? Okay, so I'm going to talk about this one question that is on your homework and it also is on your worksheet. The only reason I put it on the worksheet is because it appears on your homework so much. And I just think it's a little challenging, so I want to show you guys how to do it. So it says the perimeter of a triangle is 32 feet. So obviously a triangle is a shape with 3 sides. So we have 1, 2, 3 sides here. Just drawing a picture can really help us visualize what's going on. It says one side of the triangle is 11 feet longer than the second side. The third side is 9 feet longer than the second side. So what I'm going to do is say one side that has length x. Oh, did I like mess up the verbiage of this question when I wrote it down? The perimeter of a triangle is 32. One side is 11 feet longer than the second side. Oh, okay. Sorry. So I need to be really careful on how I write this down. It says one side of the triangle is 11 feet longer than the second side. The third side is 9 feet longer than the second side. So notice this statement right here and this statement right here are in reference to the second side. So the second side is the thing that we really don't know. So I'm going to say the second side has the length x. And now, since I've given the second side a length, now I can write all of the lengths together. It says one side is 11 feet more than the second side, and the third side is 9 feet more than the second side. It actually doesn't matter what I call this. This could be the third side, the second side, the first side, just so long as I have my baseline side, because these are in comparison to the second side. So once I add a variable to the second side, I immediately have equations involving the rest. But what I do know is if I add all of these sides together, I should get 32 feet, because the length of the perimeter of all the sides is 32 feet. So x plus 11 plus x plus 9 is 32 feet. I add those parentheses just to be clear that I'm adding 3 separate different things. The parentheses don't matter because I'm just adding all of them. So I have x, and x, so I have 3 x's plus 20. That's me adding 11 and 9 to get 32. I'll subtract 20 out to get 3x is equal to 12. Divide both sides by 3 to get x is equal to 4. So the second side has length 4. Second side. The second side has length 4. So let's figure out what everything else is. This is going to be 4. This is going to be 4 plus 11. It'll be 15. And this will be 4 plus 9. So it'll be 13. So the length of each side is 4, 15, and 13. And you're done. I guess I didn't have units, so we'll say feet. So when you guys see this type of question on your homework, what you need to do is identify what the baseline is. The baseline is the second side. So all you need to do is add a variable for the second side, and then the equations involving the third and first side, or however you want to orient it, just pop out of the expression once I add a variable to describe the unknown quantity, which is the second side. Okay, I have a couple of more questions. This one might be again a little bit more for your homework than what I want to quiz you guys on. Find the dimensions of a shipping box. Dimension of a box. Given the length is twice the width, the height is 8, and the volume is 1600 cubic inches. So, just like above, can I draw that a little bit better? Here's my length, width. Maybe it should be the other way around. Maybe this should be width and length and height. Just as before, let's read this very carefully and see what equations pop out when we translate the English into math. It says the length is twice the width right here. So length is twice the width. We know also that height is 8 inches right away. There should be an inches right here, inches. So height is 8. We also know the volume is 1600 cubic inches. And just like I said above, when I wrote this box up here, if I am to solve any equation involving this concept with 3 unknowns, I'm going to need 3 equations. And here are my 3 equations right here. So let's put down some of these concepts. Let's rewrite this or redraw this box with the given unknowns that we have. Or what we call them are constraints, the things that must be true, that constrain the solutions to our problem. Here is width, but I do know that the length right here must be 2 times width. So what I can do is get rid of length and say, oh, whatever width is, the length is just 2 times the width. I also know the height must be 8. So that's me incorporating this part and this part. The only remaining portion I have is to incorporate this part. But how can I relate this box that I've drawn with this volume that must be true? Any suggestions? So I know the volume of this box must be 1600. So let's write down an equation for the volume of this box. It is W times 2W times 8 is equal to 1600. Width times 2W times 8 must be 1600. I know the volume must be 1600. So we'll multiply this through to get 16 times W squared is equal to 1600. Now what I'm going to do is divide both sides by 16 to get W squared is equal to 100. And what I'm going to do is take the square root of this to get a number. So what I'll have is W on the left hand side, and this is something that we haven't talked about. We'll talk about maybe next class actually. Technically, we get plus or minus values out here. So the square root, when I take the square root of W squared and 100, W could be 10 or negative 10, because if I were to recheck the solution and say, is negative 10 squared equal to 100? And is 10 squared equal to 100? Both of those statements are true, right? So they are both solutions to the statement. But does it make sense to say the length of a box is negative 10 centimeters? No, right? We are only going to pick the positive one. So I'm not going to write that plus or minus. We don't have to worry about that quite yet. That's tomorrow. But I do know the width is 10 centimeters now. So now let's go back up and answer the question. I know width is 10, so I'm going to go all the way up here and plug in 10. So the dimensions of this box are 10 centimeters by 20 centimeters by 8 centimeters. That's the dimension of our box. Any questions so far? So, like many things in math, this is not something that I expect students to be good at right away. This is not like you need to understand how to do all of these questions right now and be able to solve any curveball I throw at you. If you look at the worksheet, those are the type of questions I'm going to ask you. So I'm not going to ask you any three-dimensional objects. It's going to be, rectangular paper or making some function describing the cost of something over a period of months or something like that. And then maybe I'll ask you the triangle question on a quiz. I'm not sure yet, but what I've done is I've restricted the word problems to the ones that are on the worksheet. I'm giving myself the degrees of freedom to change the numbers if I want, but they will be questions like that on your quiz and exam. So don't fret on the vastness of the number of questions I can ask you. This box one is more for your homework. I think I did see it pop up once or twice. So if you do see it, you have some idea on how to get through that. So now the last bit of today is going to be kind of general algebraic problem solving techniques, because there can be some pretty challenging questions to solve, just algebraic ones, not even, word problems, just things that if I give you some complicated equation, solving for the unknowns. So let's try one. Solving harder equations. And I'm going to do a couple examples, and I'm going to tell you what the takeaway from solving any question similar to that will be. So as an example, 1 over p plus 1 over q is equal to 1 over f. Solve for f. So I'm going to write this in a deep crimson red to warn you about this. You cannot flip this equation, meaning you can't do this. I can't flip this fraction and flip this fraction and flip this fraction and say, oh, those are all algebraically equivalent. But the general concept is actually what we'll use to correctly solve this. What I want to do is eventually cross multiply, because in order to solve for a variable that's in the denominator, I want that variable to make it to the numerator, because when I make it to the numerator, I can then do more basic algebra to solve for that variable specifically. But when I have two fractions summed together like this, I can't do that type of algebraic manipulation. It's too difficult. So what I'm first going to do is combine. How do I combine 1 over p plus 1 over q? If you guys want to shout out the simplified fraction, that's also totally fine. So what I need is a common factor between these fractions. So that's going to be p and q. So what I'm going to do is multiply by the missing factor. Do I need to do the same thing on the right-hand side? Any ideas? Should I multiply by q over q and p over p on the other side as well?
Yes.
So in general, when we multiply by things on equations, if I do it to one side, I have to do it to the other. But right here, all I've done was multiplied this by 1 and this by 1. So if I wanted to, I could multiply this by 1 and this by 1. But that really doesn't change it. Nothing has changed over here. So I don't need to, if I multiply by a factor of 1, I don't need to do that type of compensation on the left and right hand side. These are just 1. So nothing has changed. The only thing that has changed, though, is they both have the same denominator. So now I can add through their numerators. And now what I can do is I can cross multiply and flip these fractions. So I'm going to multiply f to this numerator. And then what I'm going to do is multiply this fraction over to the other side. But let's be careful. This is kind of confusing. I will multiply f over to the left-hand side. So that is something I'm going to have. But what I did really in order to get this variable, this fraction to the right-hand side, what I'm going to do is divide by it. And I'll show you without cross multiplication what I'm going to do. In this line, what I did was I multiplied f over here. So I took that variable f, multiplied it on both sides to get f times q plus p over p times q. And that was equal to 1, because f times 1 over f is 1. And then in order to get f alone, what I did was divided by this quantity. On both sides. So now this cancels as 1, and that's where we are over here. How do I simplify this complex fraction, though? Any suggestions?
Multiply by the reciprocal.
Yep, exactly. So the way I always imagined it in my head was, what I would do is I would like grab the bottom of this fraction. So maybe I can like draw a little fist. There is my beautiful hand. And I always imagine I'm grabbing the very bottom of the fraction, then I'm flipping it up to the numerator. That visualization helped me a lot when I was learning this. So then I have P over Q, or P times Q over Q plus P. That's my final answer. So F is P times Q over Q plus P. So what is the takeaway from this question though? Well, if the variable is in the denominator, life sucks. It's hard. But when you have fractions like this, what you want to do is first get this equal to a fraction equal to a fraction. This right here, you have two fractions equal to a fraction. So you need to do some type of simplification in order to get it a little bit easier. Because notice I can only start doing this type of algebra when I have a fraction equal to a singular fraction. If I have this sum or difference of fractions, the algebra is much, much less straightforward. But this general premise will be the same thing as you always do. So I will write this in blue. If variables up here in the denominator your goal should be to write the equation as a singular fraction equal to a singular fraction. Then start cross multiplying. Then start cross. And that's all we did here. We had a non-single fraction, so two fractions, equal to another fraction. And what we did is some algebra in order to get it to a single fraction equal to a singular fraction. Then we started cross multiplying. Then really the equation just kind of, came to us at that point. Once we had f, all we needed to do was divide by some stuff in order to get f alone. Any questions about that example? Okay, so I want to do another type of question. This is when a certain variable appears in multiple ways in the same equation. So I'm going to say, actually, I think I have a couple of examples like that. Area is 2 pi r squared plus 2 pi r h. Solve for pi. Actually, I'm sorry. This is the one I put on the worksheet. I want to do a slightly different one. I want you guys to work through that one on your own. I don't want to just, give you the answer right away. Struggling is good. in math. Struggling is how you learn. Solve for W. So notice W appears in two different ways in this equation. It appears twice. Does anybody want to volunteer a general idea? Like maybe they know from a previous class or from high school, when I have variables appearing in multiple terms, what should be the guideline on me solving for that variable? So, idea. What we're going to do is gather all terms with the desired variable on one side of the equation. Shoving all unimportant, and I'll say things because maybe those things are numbers or other variables, but they're not the ones that we want. So shoving all unimportant things to the other side. Once I have all of the things that have W, or the variable that I want, on one side, what I'll do is then factor out the desired variable. Then divide by that factor to achieve the desired variable alone. And I'll show you what I mean by that in this example. So I have this 2 times all of this stuff. So first what I need to do is distribute that. So S is equal to 2 times L times W plus 2 times L times H plus 2 times W times H. So I'm trying to solve for W. Here's a term that has W. Here's a term that has W, but this guy does not have W. Don't care about him. So I'm going to get rid of him and put him to the other side of the equation. So on the left-hand side, I have S minus 2 times L times H, 2LW plus 2WH. So I've achieved most of the guidelines now. I have all the terms that involve the variable that I want on one side of the equation, and all the things that don't involve the variable on the other side of the equation. Now what I'm going to do is factor out W. Notice W appears here and here. So if I factor out W, I get 2 times the quantity 2L plus 2H times W. And I'm almost there. So if this was something equal to 2W, I would solve for W by dividing by 2 and then dividing by 2. And we're going to do the same thing with this expression on the right-hand side. What I'm going to do is divide by this quantity, 2L plus 2H, and this quantity, 2L plus 2H. So my final answer is that W is S minus 2L times H over 2L plus 2H. And that's my final answer. So these type of questions are certainly the ones you're going to find more just naturally as we progress through the course. We'll have to do a lot of things like this where we factor out a term and then solve for it. The one above that I've shown you is more of a challenge question. It's an important technique to know in solving complex, I guess, rational equations. And if you do notice right here, what we've done for solving this is much like what we did for solving regular rational equations that we did before. It's just this is slightly more compact, so its complexity can be a little bit more because there's not as many cancellations as we have, but the general approach was the same. We combined all fractions that we could and then got rid of the variable inside the denominator. So this is something that you want to know how to do if it ever occurs to you and happens, but it's not something that will pop up naturally a lot in this course. This is a much more important technique to know because it's much more general and just naturally happens in a lot of other types of questions. So the general idea is gather all terms with the desired variable on one side of the equation, shoving all unimportant things to the other side. That's what we did right here. We gathered everything we needed on one side and then factor out the desired variable. W was that desired variable, and we factored it out. Then we divided by the factor to achieve the desired variable, and that we divided by this quantity, 2L plus 2H, and we solve for W exactly. All right, so that is it for today. If you have any questions, you can stick around and ask me, but otherwise I will see you tomorrow.